Hello everyone, we're back, and we're going to jump into 7.2 real fast, multiplying polynomials. All right, let's go through and practice, make sure we know what each of these polynomials is called, and we're going to be taking these babies and multiplying them. Turns out you guys have been multiplying them the whole time. That's okay. So this here is, if you're going to name this, let's practice naming them. This is we add the exponents. This is a cubic monomial. There's one term. This one in blue, you take the highest degree. This is degree 1. Degree 2 is the highest. So this is a quadratic binomial, because there are two terms. Quadratic binomial, two terms. Second degree is the highest. Second degree determines quadratic. Two terms determine the word binomial. This third one is degree 1, degree 1, degree 1. This is a linear. How many terms are there? Trinomial. Okay, so what we're going to be doing today is we're going to be taking these in their different fashions and we're going to be multiplying them together. Now, you've already been doing this a little bit, especially in like section 5-1. In 5.1, we did problems like 6x to the third times 4x to the sixth. Okay, and when you multiply these, we can multiply in any order. So you do 6 times 4 is 24, x to the 3 plus 6, two numbers with the same base, which will give us 24x to the 9th. So there we have it. Okay, so we remember how to name them, and then we've got we've been multiplying monomials. But it turns out in quarter 1, you actually multiplied monomials by a binomial as well. So this, you guys know as the distributive property. You could distribute, you could say, all right, we're distributing the number 4 to negative 13x and to positive 9. And when you guys do that, you write it as 4 times negative 13x plus 4 times 9. Okay? So pretty straightforward. And then what we can do is come down. 4 times negative 13 is negative 52x. 4 times 9 is plus 36. So really, you could go from here directly to this answer. That'd be just fine. This is the distributive property. You were multiplying polynomials all along. You just didn't know it. Okay. Shift this a little bit. Let's take a look at this next example. Next example is 2x times 3x plus 1. So how is this any different? Well, it's not much different. This isn't much different. It's 2 times x. Okay, I'll color that in purple. And then in red, we have times 3x plus 1. So what are we doing here? Here we're applying the distributive property the same way we did before. And you can see these things kind of being passed out as you're moving through the problem. So what we have here is we have 2x times 3x plus 1 plus 2x, and I'm going to copy those other letters in as well. So that'll be 2x times 3x plus 1. So 2x times 3x and 2x times positive 1, and then we're able to simplify. And that's the process. This is a long process, but you don't actually have to do it this way. There's a much easier way to do it. You can kind of do it in your head just like we did this one. You could say 4 times negative 13 is negative 52, x, so on and so forth. So, but this time we have 2 times 3 is 6, but we also have x times x, which gives us x to the second power. And over here, 2x times 1, anything times 1 is itself, so we just have plus 2x, and that's our final answer. And that is about most of the mathematical prowess you need. Everything else is just a couple little tricks to keep you in line, and then we're going to just do a bunch more examples of all shapes and sizes. So these two are a monomial times a binomial. Both of them are. I did want to show you guys really quickly what this looks like geometrically. Like, you guys are used to seeing, like, 3 times 5 is 15. If seeing that as a rectangle, if you're finding the area of a rectangle, what does 3 times 5 look like? Well, it looks something like this. Okay, there 3 inches. If this is 3 inches by 5 inches, there are 15 square inch blocks. Okay, well, if you are multiplying, right, 2x times 3x plus 1, look like in terms of in terms of geometry? So if this is, I'm going to write this here. This section right here, that is 2x, right? If x was 6, you'd walk 6 feet, another 6 feet, which is 12, right? So this is 2 times x. And then this red thing up here, or rather the top dimension, is 3x's plus 1. And you will be able to see the answer emerge here as we're doing this math. So that is x, x times x gives us x squared, x squared, x squared, right? X times x for all these, x squared, x squared, x squared. Now the last two rectangles are 1 by x. 1 times x is x. So here you have your, geometrically we can see, you have your 6x squareds, or 6 of them, and you have your 2 x's. Pretty exciting. Okay, so now I'm just going to jam through a couple examples. We're going to make them a little more complicated this time. We're going to be doing a monomial times a trinomial, but the process is the same. I'm not going to write the kind of expansion step that I did before. We're going to go through and do each of these individually. It's the same process. So I like to go through and kind of think about the number first and then the variables. Think about them separately. -4 times +2, a negative times a positive is a negative. And then m to the first times m to the second is m to the third. Okay, let me just do this process again. A -4 times a +1 is a -4 m, this is m to the first, and m to the first, which will be m to the second. -4 times -2, a negative times a negative is a +8, and there's no m there, so the m from -4m comes along. So we have a negative number, which is going to change all the signs of the things on the inside. It is positive, positive, negative. Here it's negative, negative, positive. And multiplying by m increases the power. It went from 2 to 3, from 1 to 2, from 0 to 1, so on and so forth. All right, you guys try this one on your own, and unpause the video when you're ready to see me work it. It is right here. Okay, let's get started. Same thing, 7 times 1 is 7. Y times y squared is y cubed. 7 times -8 is -56y. Y times y is y to the second. 7 times +4 is +28. Don't forget the y on the end is attached to 7. All right, cool. Some expressions, you got to be careful when you're done. Some expressions are not simplified after you do the distribution. So let's take a look at this one here. Remember, you only distribute to the things that are inside the parentheses. So if we move forward, this would be 8x squared minus 40x. 8 times 5, -5 is -40. But we still have this plus x minus 10 coming along. Those don't change. So we got to go through here and we have to find the like terms. So like terms are terms that have the same variable and those variables have the same power. That's these two. They're both x to the first power. And that's going to end up -40 plus 1 is -39x. To get our final answer here, we'll have 8x squared minus 39x minus 2. So make sure you combine like terms when you're writing your answer. These we can't combine. We can't add any of these because all the y's have different powers, all the m's have different powers. Okay, so I've got a little bit of a metaphor that I'd like to use here. Multiplying polynomials is a lot like going to a party, going to like some sort of a celebration, wedding, gathering, camping, whatever, what have you. When two cars pull up into the parking lot, and if they're all, especially I like the wedding metaphor. If they're all there, then you're probably connected to that, the people that show up, right? So the method that I always teach my students is multiplying binomials is like two cars that roll up to a wedding, to celebrate something. So these two people, the parentheses represent the cars. We're multiplying them. These two people know each other. They don't need any introductions. These two people know each other. They don't need any introductions. However, this person in this car needs to introduce themselves to both people in the other car. Okay, x times x is x squared. X times 7 is plus 7x. That's great. Lots of introductions have happened. However, this person has not introduced themselves. Okay, so they're going to make their introductions. So that'll be plus 3x plus 21. The reason I use that metaphor is it makes sure that nobody is missed. Everybody from the first car needs to meet everybody from the second car, or vice versa. The second car could have made the introductions, and you'd end up with the same. Situation. Okay, so now we got to go through. We're going to combine like terms. Here's our two like terms, 7x and 3x. Those are going to add up to, 10x. And then we can come back. I wish I had a hotkey for this ink. X squared plus 10x plus 21. That's it. Bring the other ones down, and we are all done. That's how you multiply two binomials. Now, it used to be taught, at least when I was in school, and I've still seen it pop up in textbooks. They teach first outer, inner, last. Okay. Some textbooks still teach first, outer, inner, last. This only, gosh dang it, I did it again. This only works when you are multiplying two binomials. This is specific to two binomials, and I don't like rules. So first being the first thing in each group, outer being the x and the 7, inner being the 3 and the x, last being the 3 and the 7. I don't like this rule very much because it only works for situations like this, and it fails to work if one of them is a trinomial. So I like what I call the car method or the party method. These two cars are rolling up to a parking lot, and they need to make their introductions. So everyone from the first car needs to introduce themselves to everyone from the second car. Okay, let's do another one. We'll try this one, and then you guys can pause the video and try it on your own if you'd like. Okay, here we go. Moving on through, that's going to be 3y times y. 3y times 5 is 3y squared plus 15y. 3y squared plus 15y, double check my work. So this person introduces them to both people from the other car, and then this person introduces themselves to both people from the other car. So you end up here with minus 4y minus 20. Combined like terms are the two terms that both have a y to the first, right? This is a constant, this is y to the second. They don't have any like terms, these ones do. So now we can go on, add those together. That's going to be 15 minus 4 is 11y, and the other two are going to come down, equals 3y squared plus 11y minus 20. And there we have it. Okay, great. So what about a situation where, so you guys can try this one if you want. I'll just work through these if you want to see more examples, but it's really, you can get really quick at these, and I'll probably do these without do the color changes. X times x is x squared. It'll be plus 6x plus 2x. So there's the 6x, there's the 2x, and then 2 times 6 is plus 12. Simplify at the end to get x squared plus 12x, plus 8x plus 12. Great. All right, and I can skip that one. All right, so what do we do if there's three terms? Well, this is where the FOIL method doesn't work. FOIL method has been foiled. Okay, so what you have to do is the same thing. Everyone from the first car has to introduce themselves to everyone in the second car, or vice versa. So this person is going to go to every person from the second car. Don't go to the 4 because you know him. You guys rode in the same car. Okay, so you're going to introduce yourself. This person's going to introduce themselves to everyone from the second car. So that's going to be x times x squared is x to the third. X times 6x is plus 6x squared. X times minus 3 is minus 3x. In red, multiplying on the bottom, negative 4 times x squared is minus 4x squared. Negative 4 times positive 6x is minus 24x, and negative 4 times negative 3 is plus 12. All right, and now we can go through and combine like terms. So where are our like terms in this scenario? Okay, let's start with x to the third. There are no other x to the third, so that one comes down. Start with the highest degree. X to the second, there's one there, and there's one there. Add those together, and you'll get plus 2x squared. Negative 6 minus 4 is positive 2. All right, let's grab another color, and then x to the first, so right here. Let's see, negative 3x minus 24x is negative 27x. And then lastly is just our plus 12. So you can see those joining up there. Perfect. All right, that's our final answer there. So you guys can try this next one, and then take it away. The next one, you guys can try this one if you'd like. Give it a shot. Let me know what you get. We'll see what happens. All right, there's two ways you can think about this. You can think about everyone from the second car introducing themselves to the first car. That turns out to be just fine. Or you can do it the other way. So this way, we only end up using 2 colors, but I'll just not use colors because we need to learn how to do it that way too. So let's do it this way. Everyone from the first car introduces themselves to everyone from the second car. So x to the second introduces themselves to x. That'll be x to the third. X to the second introduces themselves to 9. That'll be plus 9x to the second, right? Okay. 8x introduces themselves to x to the first. X times x is x squared, so it'll be plus 8x squared. And then 8x introduces themselves to 9, which will be plus 72x. Okay, lastly, negative 2 introduces themselves to x. That is minus 2x, and negative 2 introduce themselves to positive 9, which is minus 18. And now we can go through and find those like terms being the 9x squared and the 8x squared, which will result in x cubed, there's no other x cubes, plus 17x squared. And then, so x squareds are taken care of. Now x to the first power, 72 minus 2 is plus 70x minus 18. So I hope that worked well for you. All right, last one. For these, finding the area of the purple region. So to do this, I want you to think about a simpler example. I'm going to erase this, but what if we had a block that was like 3 by 10? There would be 30 little tiny 1 square inch, if these were inches, would be 1 square inch blocks in here. Now what if I came along and I sliced out a block that was 2 by 3? Well, and we wanted to find the area of paper that was left over. Well, to do that, we would take 3 times 10, which is 30, and we would subtract off 2 times 3, which is 6, to get a total of 24 square inches left over. So if we cut this square out, how many square inches of paper would be left over? Well, it's the same idea here. So the way that we do this, the way that we write this, is we're going to say the total area is equal to the area of the big rectangle minus the area of the small rectangle. Okay, so we're going to have to find, I'm going to put these in big groups of parentheses. That's key. If you don't use parentheses here, you're going to get a funky answer, so please be careful. Yeah. So we need to find the area of the big rectangle. So compartmentalizing the problem here allows us to really focus on what's important, one thing at a time, and we can kind of take it from there. So on the inside, the area of the big rectangle, so we're looking for the area, not the total area, rather, I'm going to clarify, this is the area of the purple region. So the area of the big rectangle is this one, will be x plus 10 times x plus 5. Okay, so that's on the inside there. And the area of the small one, I don't know if you can read that, it says x times x plus 3. The area of the small one is just x times x plus 3. Okay, so let's go ahead and simplify from here. So what we're going to do is here it's going to be x squared, and this is where we would foil, or not foil, or foil. We'll use the car method. We're going to multiply out and think about each of these in the problem, which will give us x squared plus 10x plus 5x plus 50. And I switched the order of those, but it's still the same. Okay, and then over here will be x squared minus 3x. So you got to use these parentheses because you got to make sure you're subtracting everything from the small triangle, which really means when we're doing this, I'm going to combine these two to be 15. So it'll be x squared plus 15x, 10x plus 5x plus 50. And then I'm going to subtract x squared, and I'm really kind of distributing a -1 here. So I'm minusing x squared, and I'm adding 3x. And now we can combine like terms. X squared minus x squared is 0. 15x plus 3x is I think that is supposed to be, that's the issue. This is supposed to be plus, and I caught it. I caught it, folks. This is supposed to be minus. Thank you for your patience there. Thank you for your patience, imaginary viewers on YouTube. I appreciate that. X squared gets canceled out, so 15x minus 3x is 12x, and then we have plus 50. So this will be the simplified expression for the area. It doesn't matter what x is. X could be 2, 3, 5. This will represent the area of the purple region when we're done. Glad I caught my mistake. All right, that's it. LeVar Burton approves. Hopefully you guys can see that okay. Appreciate all your hard work. We'll see you next time.